Two ways to tell the beginning. Two beginnings? On one side, creation stories speak of purpose and meaning. They describe a world called into being, ordered, cared for. These stories differ across cultures, yet they share wonder. On the other side is the scientific method. It asks questions, tests ideas, and follows evidence. By measuring light from the cosmos, it builds a careful story of origins. That modern story begins with a hot, dense universe that expands. Not an explosion in empty space, but space itself growing. We will walk it gently. Simple words, clear pictures, steady steps. No judgment between paths. Different questions, different tools. Here, our focus is the scientific path and what the evidence shows. Look up and come along. The universe had a beginning, and the story is our story. When you hear the phrase, the Big Bang, your mind might picture a huge explosion, like a bomb in empty space. That's a common idea, but it isn't what the theory says. The Big Bang was not an explosion in space. It was the beginning of the expansion of space itself. From that moment, the universe began a long journey of growth and cooling. All of space, all of time, all matter and energy began. It is the beginning of the universe as we know it. Imagine a single point, not sitting in a void, but containing everything. The universe was incredibly hot and fantastically dense. Galaxies, stars, planets, everything emerged as space stretched. There was no outside to expand into. This expansion has gone on for about 13.8 billion years. How do we know the universe is expanding? In the 1920s, Edwin Hubble measured light from distant galaxies. He found the light was stretched, redshifted, like a siren dropping in pitch as it moves away. Redshift shows the source is moving away. The farther the galaxy, the greater the redshift, the faster it recedes. Space is a stretching canvas carrying galaxies with it. Run the movie backward, smaller, denser, hotter. All matter and energy once packed into a tiny, energetic state. The expansion we see is the legacy of that beginning. Modern telescopes confirmed and refined these measurements with great precision. It is a cornerstone of cosmology, a fundamental fact of reality. If the universe began hot and dense, some leftover heat should remain. In 1965, Arno Penzias and Robert Wilson found it by accident. A faint hiss from every direction, day and night, that wasn't from Earth or their instrument. They tried everything, even cleaning pigeon droppings, but the signal stayed. It was the echo of creation, the cosmic microwave background, the oldest light in the universe. For 380,000 years, the cosmos was a hot fog of protons, neutrons, electrons, with light trapped inside. As it cooled to about 3,000 degrees, electrons and protons formed hydrogen. Light was set free. The universe became transparent. Expansion stretched that light into microwaves, just a few degrees above absolute zero. Satellites mapped the CMB in fine detail, revealing tiny temperature ripples, about 1 part in 100,000. Those ripples were the first seeds of everything, galaxies and stars. Like finding warm embers from a fire lit billions of years ago. The third line of evidence comes from the chemical makeup of the universe. In the first few minutes, the universe was like a colossal fusion reactor. Protons and neutrons fused to form the lightest element, nuclei. This process is called Big Bang nucleosynthesis. It predicts 75% hydrogen, 25% helium, with tiny amounts of lithium and deuterium. After about 20 minutes, cooling stopped further fusion. Measurements of ancient gas clouds and old stars match these predictions remarkably well. It's like finding the original recipe and seeing it matches the cake before us. A deep agreement between theory and observation. The universe didn't jump from smooth heat to galaxies overnight. It took hundreds of millions of years, guided by gravity. After 380,000 years, the universe became transparent and entered the cosmic dark ages. a vast dark sea of hydrogen and helium with tiny density variations. Gravity pulled matter into slightly denser regions. The rich got richer. Small ripples grew into big clumps, the seeds of everything. As clouds collapsed, their cores heated and compressed. Eventually, nuclear fusion ignited. The first stars were born. They were giants, hundreds of times the sun's mass, burning hot and bright. Short lives, violent deaths. Supernovae forged carbon, oxygen, iron, and spread them across space. Enriched gas formed new stars and the first small galaxies. Mergers over billions of years built spirals and ellipticals. Galaxies trace a vast web of filaments, clusters, and enormous voids, the cosmic web. But visible matter, stars, gas, dust, isn't the full story. Galaxies spin too fast to hold together without extra gravity. Dark matter. Dark matter doesn't emit, absorb, or reflect light. We infer it by gravity. It's the invisible scaffolding that sped up galaxy formation and shaped the web. Then came a shock. Expansion is accelerating. Something pushes space apart. Dark energy. About 5% normal matter, 27% dark matter, 68% dark energy. The Big Bang explains the universe well from a few seconds onward, but big questions remain. Why is the CMB almost the same temperature everywhere, even across regions that couldn't have interacted? This is the horizon problem. And why is space so geometrically flat? A delicate initial balance. Cosmic inflation was proposed to solve these puzzles. In a tiny fraction of a second, space expanded exponentially, faster than light. Relativity isn't broken. Space itself expanded. A small, uniform region stretched huge, explaining smoothness. Stretching also flattens any initial curvature. Tiny quantum jitters became the seeds of galaxies and clusters. The idea fits data well, but scientists still seek clear, smoking gun signatures in the CMB. If found, they would confirm an event at the dawn of time. Let's take a calm step back and see the grand narrative. Our universe began 13.8 billion years ago in a hot, dense state. Not an explosion in empty space, but space-time expanding. The Big Bang is supported by three pillars: expansion, the CMB, and the light element abundances. From a simple beginning, physics shaped the universe. Gravity amplified tiny bumps into stars, galaxies, and the cosmic web. Stars made the heavier elements, carbon and oxygen, needed for life. We are made of stardust. Our existence flows from this cosmic story. Yet most of the universe is dark matter and dark energy, still mysterious. The first moment and inflation sit at the edge of our understanding. But our curiosity drives us forward. Keep looking. Keep asking. Stand in awe of the story the universe tells.